So we're going to be talking about vectors and matrices. Again, this is a course on data-driven modeling and scientific computation. You can find more information at my website, and also I'd recommend you downloading or cloning this GitHub site, which will have all of the codes we use, including those in this lecture. So the main thing we want to start with, this is a very basic beginning, is the idea of vectors and matrices. Everything you're going to do within programming languages is you have to arrange your data or manipulations, and all of this is going to be done by construction of what we're looking at here, which are vectors and matrices. So one way to think about a vector, it's a really skinny matrix. In other words, a vector either has a single column or a single row. And so what you're seeing here is this is a row vector, layout of numbers 4, 12, 1. And this is a column vector, which they are laid out vertically. So we can work with row or column vectors, and a matrix is typically a rectangular structure which has a certain number of rows and columns and arrangements of data. So this is essentially the filing cabinets of our world. This is how we're going to manipulate data, store data, do mathematical representations of every computation we're going to do is going to sit here within vectors and matrices. So it's really important that you're fluent in understanding how to manipulate these, how to extract information from them, and how to create them. So let's start off with creating some very basic vectors first, then we'll move on to matrices. So within Python, here's what we're going to do. We're going to import np as npi, and numpy as np. So now almost everything we're going to do, we're going to have to put np dot in front of it because we're calling on this numpy library. So for instance, what I'm giving you here now is going to be 3 different ways to create a vector. So x1 and x2, x3. Notice what it is here is a vector 1, 3, 2. But here I could do np array 1, 3, 2 or np matrix 1, 3, 2. And I can display all of these, and what I've actually done in creating these is created something that looks like this. It is a row vector with 1, 3, 2. And again, different ways to construct this, right? I can use different architectures to build this specific row vector. But the thing here, the commas, just tell you go to the next component. So this is how you create a row vector. There's that row vector. You could alternatively make a column vector. So the 1, 3, 2, I could make it instead into a column vector. And what you're going to notice here is I could do np matrix. Notice what I've done here. Within the brackets, I have a bracket, comma. So every time the bracketed structure, and with the comma, it says go to the next row. Okay, so what I've done here is created 2 versions, np matrix or np array, both of which create the following column vector that we want to do. So we can create row vectors, we can create column vectors very easily within the Python architecture. We can also automate much more generic types of matrices or vectors. And so for instance, I've created here a series of vectors. And let's talk about what these are. Let's go through the first one, x1, np arange. So what this does, arange goes from 0 to 10 in steps of 1. But here notice I went to 10.1. The way Python works, it starts as 0 and steps forward in steps of 1, which is specified here. And if I don't specify anything, it will always default take steps of 1. But it won't include 10. So for instance, if this goes forward 0, it goes 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. 10 is the last value, except it won't include it, but I put 10.1, so it will include 10 because 10.1 would be the last value. So this would create a vector from 0 to 10 in steps of 1. Here I'm going from 0 to 10 in steps of 2. So this is 0, 2, 4, 6, 8, 10. And again, if I had made this 10, it would go 0, 2, 4, 6, 8. It's really important you understand Python indexing when it comes to making something like a range, because a range does not include the last value. Okay? Here we can steps in non-integers, so from 0 to 1.2 in steps of 0.2. So this is going to go 0, 0.2, 0.4, 0.6, 0.8, 1.0. It won't include 1.2 because that's the last value. Fourth one here, 0 to 9 in steps of 2. So it's 0, 2, 4, 6, 8. That's what that will generate. And again here, 0 to 5. This will go from 0 to 5 in steps of 1. So it goes 0, 1, 2, 3, 4. It won't include the 5. So these architectures, which are very simple, it's really important you understand the indexing, because this is where you can make a lot of mistakes in your code if you don't index this thing correctly. Okay? So that's how you would create some vectors. These are going to be row vectors. We can also make matrices. So here's the matrix A that we're making. We're going to use the command nparray, and here's the first row of this, 1, 3, 2. And note it's in brackets, right? So I've got brackets surrounding these, 1, 3, 2. And then so now I'm going to go to the next block, 5, 6, 7, and then 8, 3, 1. So those are going to be my 3 rows, all stacked on top of each other. Now for nparray, I have to have always, for every single row, it has to have the same number of components, same number of columns. So just keep that in mind if you write these things. But this thing here will just then create this matrix right here. 1, 3, so okay, that's the matrix we created from this command here. Now one of the things that we might want to do is manipulate this matrix. So what Python will allow us to do is access components of the matrix. And this is really important for us to be able to be, again, very fluent with, because oftentimes when we're doing our scientific computing, we're grabbing portions of vectors and matrices in order to perform some operation. And so you have to be able to access the different components very easily. So for instance, let's go walk through these 3 commands here. We've created 3 new vectors, or 3 new components. x1, which is this matrix A, 1, 2. So this is, again, the first denotes the row, the second the column. So column 1 is actually the second. So row 1 here is actually the second row. Remember, Python indexes starts from 0. So there's a 0th row and then the first row. So it says goes to the second row, and since this is a 2 here, it's the third column. So what this is going to pull in, if we look at this matrix here, second row, third column is going to be that 7. So when we do that, in fact, that's what this is going to be. It's going to pull out that 7. Let's look at the second component, x2. What x2 is doing is actually pulling in A, go to the second row, and then when you put the colon there, it means grab all of it. So it's this whole second row. So, and with the column, so it's going to go grab the second row of this matrix, and there it is, 5, 6, 7. And then finally the third one, the colons are there, so it's go grab all the rows, and then in fact, what column is it? It's the third column. And so the third column, there it is, 2, 7, 1. So this is, again, efficient manipulation of that matrix by just being able to pull out the components we need for some other operations we actually want to do when we start getting to real scientific computing. You can also transpose a vector. In other words, you can take a row vector or a column vector and turn it to its opposite. So if you take a row vector, you can turn it into a column vector just by simply this transpose command, which is the .t right there. Okay? So you take that 2, 7, 1, and it's going to lay it on its side. We can also, this is very important because when you transpose, this is different than, say, MATLAB. If you transpose a complex number, it just simply, again, transposes it without doing any complex conjugation. This is very different than MATLAB, which will actually do complex conjugation. So here, no complex conjugation, but if you do want to do complex conjugation, you use the conj command. npconj x will actually take any value of I, turn it into -I. So that's the command line for this. So if I make this vector here, which is exactly this vector here, which is complex, and the j here, by the way, the 2j, the j here is the square root of -1. Okay, that's the imaginary number I. Okay, and then this here, this is the command that will essentially take the complex conjugate of it. And so that will give you this row vector from your initial starting value vector, which was a column vector. So these are the manipulations you can do with your vectors and matrices. There's even some more advanced manipulations you can do. You can take something like this vector here, which is a series of 5 numbers, right? So it's a row vector, and I can start doing different things with this. I'm going to show you what this looks like. So for instance, I'm going to make a new vector, x1, which is x greater than 0. So what it's going to do is going to basically create for me, in fact, let me walk you through what it's going to create. It's going to create for me this vector here. So it's going to look at, so this command here looks at all the components that are bigger than 0. And if they're bigger than 0, they assign a value of 1. If they're less than 0, they're ignored and they're assigned a value of 0. So if you look at this, I have a negative number, 3 positives and a negative, so it gives me 0, 1, 1, 1, 0. Okay? So that's the first thing I do. Actually, this is what the y1 vector is. So I'm taking this and multiplying by 1. Okay? But I can also take this same operation, multiply by x, and so what it's going to do is multiply back through by this vector, and I just get all the non-zero components out, or sort of the positive components out. The negatives are dropped, or they become 0. Or this third one, I can just take this thing, multiply by 3, and I get something like this. So you can see there's sort of some really nice ways to manipulate matrices, pull out all the positive values, pull out all the negative values, set everything else to 0. These are the simple commands that you can do versus you having to write some kind of loop to do this. So Python has built in quite a bit of functionality there for us to use, and we want to use it as we go along. Again, you can find more information here at my website. And this is going to be all about data-driven modeling and scientific computation. Follow along. Just have a playlist, and then you can just move your way through the book that is associated with this.